Good morning. My name is Scott Sheahan. My talk today is going to be on motorcycle security, a project that I've been working on. This is from research I did back in January of last year, and we'll get into the story. Let me get set up here. So here's the bike. It's an Indian Scout bobber with tech. I had to get the tech package, right? If you're going to get a bike, you ought to get the tech with it. I know Carlos is a rider, and we were talking about he has a bobber as well. So this one has some cool tech features that I wanted to test. I'll go into here. So, it's the morning. I hope you're awake. Hey, you're finally awake. Anybody know where this is coming from? Raise of hands. Anybody played that game? Yeah, I figured there'd be a lot. That is my favorite RPG game. Obviously, I'm dating myself, but it's a fun game. I actually got into it because of the music on Spotify. Its music is excellent. And in this role-playing game, you get to set your path, right? One of my favorite parts of a role-playing game is the path ahead. When you go out of the city and you leave what you're doing, you're like, I'm just going to go gain some experience points, and I don't know what's going to happen. Maybe I'll die. Maybe I'll fight some stuff, and I'm going to get some new tools, and everything's unknown. But like, you know that excitement? Like when you guys go out and are doing something new? That is what I wanted to do with this research project. And I'll tell you about the story as I get going. So who are you? This is a question you have to answer in these RPGs. You get to decide who you are, your race, your weapons, all the different things you're going to do in the game. Kind of like, well, life is the ultimate RPG, right? Get your own, you get to decide what you're doing in life. Hopefully you enjoy what you're doing at your day job. For me, I wasn't like hating my day job. I've done embedded device integration with different products for years. I graduated and went into the aerospace industry, worked on the next-gen jammer. That's for the EA-18G growlers. And they're sent into warfare spaces to like basically shoot a bunch of RF signals at different devices, and they know the radio profile. It will jam all different devices across the world that the Navy uses this for. I then went into automotive because I was an embedded developer here, and I wanted to get into security. So I went into the Ford cybersecurity team, worked on the developing car architecture. Post 2015, car architecture really changed a lot. And I got to be part of that wave of watching the modules change, the architecture change, and these hardened security defenses come into the vehicle architecture, that was really fun. And then if you're in the automotive space, you then want to go to a supplier, because that's where kind of the fun security happens at the low level. I went to Aptiv and worked on driver assistance modules. And then from there, got into consulting. I went to Neuro after that. This is in Sunnyvale, just down the road. Worked on those bots, doing some security for the platform. But then I got into consulting, and this whole progression of my career. I've enjoyed my career, but I was wanting something a little new. I was always on blue team, doing the defenses, and I wanted to get onto the red team. So as I told you, my past, I was doing heavy embedded security from chip level up, doing like hardware security module integration, secure boot from power on, coordinating the boot sequence from different microcontrollers that would come up on these modules, and doing all the real security features on control units in vehicle. But I wanted to be an embedded pen tester, and I kept having this discussion with my manager, which was, well, how can I get on? I knew the red team. I would talk to them all the time. How can I get on that red team? And they'd be like, well, maybe in a few years, you talk. Anybody had these manager talks? In a few years, if you kind of do this stuff, you can get there. Well, that's too slow. So this conflict of interest was just always binding me out of like going where I wanted to go. So in the game, right, you have to have this quest and this large goal and go out on a new path, try to defeat the dragon. There's a lot of good talks on these quests that you go on. But you have to have a goal, and so for me, it was like, I'm gonna go out on a new journey. From blue team, I have to get to red team. How do I do this? And I figured the only way I do it is on my own, but I had to have some help, maybe a push. And so I got laid off from a corporate security team. The business took a whole new role. They weren't going to do embedded security, so I got laid off. And the team got laid off. And so I thought, okay, maybe this is a perfect opportunity. I'm going to start doing it myself, DIY, do it yourself. And that's a big principle. All of you, I know this room is full of people that you do it yourself. If you need a tool, you make the tool. If you need the firmware, you write it, or maybe you have an LLM help you write some scripting and different firmware as well. But you do it yourself. And let me give you a minute of history. So I live in farming country in Indiana. I'm wearing my Hawkins, Indiana shirt. We don't have Silicon Valley there. We have Hawkins Lab. If you've seen Stranger Things, we have lots of fun. No, we don't. Well, in the show, they have lots of different creatures. For me, I just live in the farming town area, and this is a previous building. They call this a pole barn in Indiana. And I bought this home from a farmer, and he used it to fix his tractors. I'm going to turn this into where I do my research. And so there's me and my dog in early January. So there's me starting to frame out what's going to be my research space. Do it myself, right? Me and some friends, we helped frame this. We got it framed. We got it semi-finished, starting to work. I'm doing contracting on the side while I'm doing this. I'm writing some HSM firmware and doing defensive consulting because, again, that's how I make my money. I was making my money, was defensive consulting at the time. Writing low-level firmware for HSMs, doing security integration. But again, I wasn't to my point of red team yet. And also on the side, right, I had a side quest. I wanted to get a motorcycle license. And I thought, okay, I can combine this with my consulting gig. It's continuing education. I can buy the bike for the consulting company, and I can research on it, right? It's a business expense. Win, win, win. So that's what I did. I took this motorcycle safety class. That was a goal of mine as a kid. I really wanted to do that, so as an adult, like, I'm going to go out and do this. I then selected my target, test drove different Harleys. There's a Harley dealer just about 10 minutes down the road from where I live, and then there's an Indian dealer about an hour away. I test drove the Indians, and I loved the bike. I fell in love with this. This is a Scout Bobber with the tech package, and this was going to be my target. So I was like, yeah, corporate expense, or business expense. Cha-ching. I started my inventory. Okay, RPGs, right? You have your inventory, your tracking. Started the inventory. I had my space now. I built it, had the bench, but nothing on it yet. Had the bike, the target, and now the progression going forward was, okay, now I need to take this apart and try to figure out how it's working. That's my lab assistant. Her name is Indy. She's a yellow lab. So this is, as I'm getting into motorcycle security.
I need to download the Hotwire motorcycle.
Not a problem. One crash course and motorcycle.
Wait. Cancel that. You are handy.
So Matrix Reloaded. Trinity needs to hardwire the bike, right? Because they need to get away. But the keymaster has the key for her. So I need to figure out how to bypass the security system. I don't have the keymaster. And also, it's not 1999. The architecture has changed on the bike. So the old way, you'd have your battery system there'd be a switch in the key cylinder. When you turn the key, it would allow the current to flow through this. We're going to go into this start sequence. You'd press the start button on your right handlebar, and it would send a signal to the starter relay, which then allows high current to go from the battery through the relay into your starter motor, and then your engine starts. And the engine on old bikes, like, it's a mechanical marvel, right? They're doing fuel mixture and combustion by mechanical means. Vacuum, the carburetor and different vacuums, springs, cams, all these different mechanical controls was the old way of before we had these electronics integrated into the architecture. So now here's the immobilizer added. Up here, we add some new modules. Electrification took place, I would say, in the late 90s, and the architecture has really changed for the automotive and motorcycle industries. Now let's go through this start sequence with an immobilizer. You have these different control units that are doing, engine controller, power controller, Immobilizer. They have their own specific function. You have, again, you still have a key, but it's probably a smart key. And it has some sort of challenge response protocol between the key and the immobilizer. And the immobilizer's job is to keep the bike or the car from moving until you've actually successfully unlocked the security system. So once that is done, and there's some sort of digital protocol going over radio frequency or maybe a physical wire between the two, then the security system is unlocked. It will allow the engine controller to actually do its function. It will unlock the security system. And then when you have all these elements, the key allowing the battery to power everything up, the immobilizer authentication, you hit the start button, then the same sequence, the starter relay fires, the starter motor goes, the engine is now controlled, but also by the digital control unit, the electronic control unit, which is the engine controller. Modern electronics doing what mechanical systems used to do. And let me go on. So I needed to disassemble my particular bike. And I lift up the seat. I start to look at these modules and figure out what is this architecture in the system. I pull out some of these modules. Here is what's called a wireless control module. The talk will be focusing on that. That is our immobilizing module of the bike. This is what's called a CAN gateway module. It bridges different segmented networks, kind of like a physical switch, but for CAN networks in the bike. And then this other one's an antenna. And also I did some disassembly on the pole barn for exhaust, because I didn't want to kill myself in the process.
You may as well take on your skier. He won't be needing it anymore.
Like any RPG, I'm getting new gear, filling my lab space with some new elements to go through the attack.
All right. Get that armor on.
I didn't kill anybody,
Give
didn't
that
take it
axe
off
a
their
few
body like in
swings.
Skyrim, but I was buying it from Amazon and different vendors. I got a new scroll in January to help me also. This is a maintenance manual for the bike, a service manual. And in here, there's a nice chapter on electrical with breakout of the electrical subsystem. And I come up with a system architecture here. So let's look up here. We have 4 different CAN networks, A, B, C, D, different units on each network with this gateway, the controller, gateway controller in the middle. And it's routing signals between the different 4 networks. This is the tech package, so it does have a cellular modem to this telematics control unit, reaching out to a cellular network. It has external USB. It has this digital round with it has a pin entry you can put on the digital round to also authenticate to the engine and unlock the security system. So that's one way to start the bike, is through the pin input. Then that goes through the digital round, through the gateway, up into this system, which is more of like the engine controller's up over here. And here's the immobilizer here, the wireless control module. So I know there's some traversal of the network from down here up to here to unlock the security system. And also up here, there's a key fob, which just directly communicates to the wireless control via RF and unlocks the security system that way. So I know there's 2 ways. And as an attacker, I was going to focus on this pin input first. We're going to focus on these 3 modules, doing the mobilizer here. The engine control module allows the engine to start, does the actual start sequence of the engine. The vehicle control module does power system, like relays turning on and off, lights to the different parts, your blinkers. And then up here, we didn't talk about the left and right hand handlebar inputs, like there's a little joystick, there's signals, there's those different buttons on that your hand controls have. And then the last one, we got the gateway in the middle, and then the digital round for the user interface down where I'm looking at my speed and the engine RPM, all the different things that supports. So I wanted to do dynamic analysis, right? This is a embedded challenge, getting your test set up where you can do power on testing and do the real world. There's not emulators, I can't run this on a PC simulated environment. I have to do dynamic testing. Got that set up. I start doing wire breakout harnesses because I want to see what's going over these wires. and I have the gateway here, and this kind of umbilical cord that would go. I found the actual connectors online, and then extended it out, and then broke out the wires to a logic analyzer, and was able to scope the signals going over that. Some essential research tools. This is the CAN Pico. It's a microcontroller with a CAN transceiver, a Raspberry Pi Pico with CAN transceiver added on as like a subboard. And it has a MicroPython SDK. You can write different functions to interface with the CAN network. Very useful for the research. So I had a couple of those. I had this Kvaser Leaf Light, which helps me sniff and understand the CAN network with their software that is compatible with that. And I'm exploring the map, right? I'm getting new information about, okay, here's the CAN bus coming up. You can see it tells you the different, you can see the messages on the wire. It's decoding those. And here is a screenshot of what you see from the Kvaser CAN King. Here's the CAN IDs, and that is, we'll go into how the CAN bus works. It's basically a shared bus network. Different node participants broadcast, they fight for control of the bus through an arbitration sequence, and the arbitration is done over this ID. The lower the ID, the higher priority it is to actually get control of the bus, and then send your message after that. So it's always, everybody's always trying to do arbitration. The lower ones go first, and it's doing this millions of times a second to fight and control who's going to broadcast messages out. Then you usually have 8-byte frame that follows within a CRC integrity check after that. And this is how the CAN bus works. I'm going to go into, this is CAN 2.0b. And the 2.0b is a subset of the protocol over the CAN bus that has 29-bit identifiers for that arbitration phase. And we'll break it out here. This is J1939, which is like a heavy trucking protocol that the bike was actually using as well. So here, the top part, think of these top 2 bytes as your message type. And it's like, okay, again, the priority is set from the beginning. So we're going to look, 0 is the highest, 7 is the lowest. Really, this is going to set your priority, and then also some configuration. We're not going to get into that. But think of this as like, okay, I can find my priority and my message type from the first 2 bytes of this 29-bit identifier. Then the last 2 are the addressing, which on the nodes, you have your destination address, what you're sending to, and then you have your source address, who you are on the bus. So every module has its own address of 1 byte, and then you're sending, and that's how you do the header for the actual format of sending these messages. So I wanted to find the pin entry CAN messages, and to do this, I did kind of an A/B test of like, okay, let's start it with the fob and see what messages are on the bus. Then I'm gonna take the fob away, take it in the home, and then see with the pin, same sort of sequence, start sequence, what are the different CAN IDs that I see come up? That was my hypothesis, right? And from the automotive industry, I have architected this, and I know some of the legacy automotive stuff. I know I'm looking for some sort of what they call a seed and key. And again, with cryptography, this is maybe key is a very bad misnomer on the old way they used to describe a challenge response. It's a challenge response. They call it seed and key. And so we'll go over this real quick. You have 2 different modules, and they're going to authenticate to each other. One will request a seed and send a message with a specific CAN ID to this one. This one's going to send the random seed back. This is going to calculate its expected key. Again, I know we have a lot of cyber folks. It's not really a crypto key. It's that token. It's the real token that's going to be checked. That module that receives the seed operates on it with some shared secret or some shared algorithm, which is up to the OEM to implement. And they create what's called the key, which is really your token, access token, which is sent back. And it checks it. It says, did this check what I calculated? And it says the status back to the module. So that's one challenge response. Happens when you're doing diagnostic testing. the same pattern happens. It also happens when two modules want to authenticate to each other. So I'm looking for that.
And so I found my first kind of breadcrumb.
Can I have you turn it up a
when
little
this
bit?
pin comes up, I was able to find a seeding key between, I'm guessing, infotainment and another one where I can come over here and play. I found the key, but I need to figure out the algorithm. But if I play that, I can get past that and start the bike. So that's a breadcrumb. I definitely found the authentication protocol between the infotainment and something else.
So I'm looking at those CAN messages. I filter down and find some sort of authentication protocol between two different modules. I can replay some of the messages. I'll get into the details on this next slide. So as I'm filtering in the Excel document of my recorded traffic, I filter and find these CAN IDs. Oh, now I messed it up. These CAN IDs in this one CDC, one CDDD range. Remember, that's the priority of this certain type of message. I see these ones are the new ones as I did that A/B test. And I was like, okay, this is, I look at it myself, and because I've architected this on the vehicle side, I see two different wrap challenge response protocols. One on the outside up here with the gray and the green, and then it finishes down here. And I see one in the middle with the pink and the blue. You can see the module IDs are 00, and vehicle architecture 00 is your engine controller generally. 1D is this module, I don't know what it is, but they're doing an authentication sequence that finishes down here. 1D and 17 are also doing some sort of authentication sequence in the middle, and one's waiting for the other. So I see this kind of wrapped two challenge response pattern. Let's go to the first one. I figure out the source address 1D is my wireless control module. That's my immobilizer. And it's doing this sort of sequence if I go into the details. Are you unlocked? No. Request the seed. Okay, here's my seed. It's these random bytes, 7 bytes at the end, always prefixed with DD. Then it waits for that second challenge response protocol to take place. And if that succeeds, then the immobilizer sends this token or key, which is back, and then it looks like the vehicle is unlocked. The bike is unlocked and ready to start. So I see the seed, I see the key. As automotive, I know the legacy pitfalls. I think, okay, let's try XOR first. Let's just try it. Observe some of these and do XOR. Oh, I keep seeing this. Yeah, this looks like the pattern of the particular secret for my bike, right? Automotive has been plagued by this. It's automotive and motorcycles. Like XOR is not a security primitive. You can do this XOR between the two values and then get your secret value back. So this particular secret value, which you get by XORing the seed and then the key, is what is operated and stored on both sides to, again, that's my secret. So I found this A6 FFFF E60D. This looks pretty static. There also I saw there's some more entropy in the last 2 bytes. Observation confirmed that this is the WCM to ECM secret. So the immobilizer getting authenticated to the engine, which allows the engine to start. So this is the first, that's the outer challenge response. Once this happens, the engine will start once you hit that start button. The inner one, which I realized was then the pin. This is the pin challenge response. So between the infotainment and the immobilizer, are you unlocked? This is another authentication. Are you unlocked? No. Give me your seed. Okay, here's my seed, prefixed by FD. Then the user enters the pin on the display. And that is used to then send back, somehow that goes into this token that's sent back for authentication. And then if that checks, there's a successful unlock with F7. And again, I'm going to XOR these. 87FFFF F7CC, what is that? Well, I know it's somehow my secret because I figured out the first one was using XOR. They're not going to change it and use AES 128 now. So XOR, use the secret value here. I knew my pin, as I knew my own bike's PIN, hex 833 or 2099 out of my key space for the PIN, which was 0000 through 9999. I did the FFF minus my PIN, and that equaled it all checked. So I was like, oh, okay, that's pretty trivial. I found the secret for the PIN entry. Again, now that if I had observed, anytime I observed that once, I can calculate my PIN, right? From this particular authentication sequence. If I were to be on the bus and watch someone walk up and put their PIN in their bike, I could get it back with this knowledge of this protocol. But most people don't use their PIN. They usually use the key fob, so I didn't think that was fancy enough. Here, I'm leveling up some experience, doing breakout wire harness creation, network monitoring, protocol analysis, and at some point, I thought I bricked my bike. I had these breakout wires, and I saw some sparks, and I was like, oh, dang. I thought I had bricked my nice new bike. I was gonna have to like tow it to the dealer and be shameful, and can you guys fix it for me? And luckily, it was just a fuse. But lesson learned on the breakout wires: don't just leave those leads hanging. This
is why you're supposed to have two.
Two bikes? Yeah. Well, I should have got two. Yeah. So where do I go from here? I can get the PIN recovery from that knowledge of that second challenge response if I observe it. If I observe it once. But yeah, again, most people are going to use their key fob. That's what I did as a user. So I can't guarantee that if I'm on the bus snooping as an attacker, I'm going to be able to recover the PIN because they're just not going to do that input. The other authentication mechanism is the primary authentication. But I do know this kind of secondary authentication between the immobilizer and the engine. So I'm going to focus on that. Like, is there a way I can take advantage of that?
But I'm bypassing the infotainment and the WCM and going directly, I think it's WCM to ECM, the wireless control module to the engine control module. It's like, actually, I just authenticated everything you can run, which allows me to then go, hey, look here, it's still looking for authentication. It's saying there's a passcode, but when I go here, I can now bypass that security system and run the bike. So.
Engine, immobilizer to engine, but wait, what? It just died. Why did it die? And I didn't know this.
And I think that just shut down.
This is like, I keep meticulous like
the first time
video records and written records when I'm doing research because my brain doesn't remember past a few days. And that was my honest reaction of like, why did it just die? I thought I defeated this immobilizer, right? So new information. It has some more defenses. So the engine starts after I play this, after I observe the seed, but I can be a participant on the bus with my CAN Pico. I can observe the seed. I can, with one observation, I now have the key to calculate and impersonate this unlock message to the engine, the token that will allow the engine to start, but then the immobilizer still kills it. So I need to understand why. Why is it doing that? There has some secondary security. So I look at the wireless control module and the pin out from that manual, and I look at these different 12 pins, I put them on my logic analyzer, and I see when I time out, I force the timeout, and these two pins are very interesting. When I time out, these two pins go low, from a high to like 12 volts to a low of 0. So I'm like, okay, well, these are pins 7 and 8, and pins 3 and 4, like, they seem to just stay high the entire time. They just look like power, 12 volt power. So my thought was I'll make a connector in the middle, and I'll splice the 3 and the 5, which are always high, to the 7 and the 8, and I'll keep that signal high, and that'll stop the bike from turning off. But as I did that, actually, I did cut the wires, and I did random luck, just started the bike, and I was able to get it to start longer before that cutoff. It usually cut off at about a minute. I got it to go several minutes, but then it still cut off again. So I was like, okay, I'm a little bit further. But yes, this was a physical means to immobilize the bike over those two wires. So the immobilizer had a physical, two redundant signals that would cut it off. And again, I figured out, okay, if I just keep these low, just by cutting them, like you're like kind of like diffusing the bomb, like cut the wires, keep it low, and actually the logic implemented on the receiving side of this signal, it was waiting for the falling edge trigger, If you never gave it a falling edge trigger, it also never shut down the bike. So if it just stayed low the whole time, it would allow me to get longer. But there was still another way it was shutting it down. And so the Mobilizer had one more trick up its sleeve, which was another secondary power off based off of the network. And when it was on the network, if it still saw that you hadn't properly unlocked through the pin or through the fob, it would send a network message to shut down. It would say, hey, you're the power controller vehicle control module. I need you to shut down because this security system still hasn't fully been unlocked the proper way. So shut it down, but just as an attacker, I'm on the bus. What if I just tell that WCM to shut up and get off the bus? And so that's what I did. Through the Can Pico, Can Hack Toolkit, Ken Tyndall, you can check out this link. It's a very extensive analysis of like the different tooling and support that the Can Hack framework has. You can just basically say, hey, target some of these messages from the WCM. If you see any of them, I just want you to interrupt it every time and cause it to be in an air loop. And this is what it sends these air loops, which is driving the bus low. And then the transceiver on this module never is able to send its successful message. There's an internal logic inside the CAN transceiver. If it does that enough, it just basically, I'm in an air state. I can't participate. It shuts itself off. So basically, I'm going to shut down this network shutdown message. And here's my attack steps for what I think is my attack. I'm going to cut pins 7 and 8 to remove that digital signal from the immobilizer to the power control module or the vehicle controller to stop that power physical shutdown. I am going to be on the bus and I need to observe either one key fob or pin authentication, the higher level authentication, but that's so I can recover the engine secret. Then, because I'm in the middle as an attacker, there's like an implant. Is Joe Grand still here? I know he had a talk yesterday on the implant on the crypto wallet. This is like a motorcycle implant, right? I need to now keep the bike from moving. And I don't know how to do that yet. But then as an attacker, when I come back up to the bike, I can signal to stop this attack, use that ECM secret to start it, and then also knock the immobilizer off the bus, so then I should be able to drive off with the bike. And mobilize the immobilizer. So that's the sequence of what my flow was going to be. The denial of service that I needed in that to stop the user of the bike from actually taking it away, I thought I'd get in the middle of this WCM, the immobilizer to the engine authentication process, and just request a new seed. So it requests a seed, but then I request a new seed, and it also gives me a new seed. So then when the check happens on the engine side, the data is stale. And so the authentication does not proceed. It is unable to unlock because it was expecting the key or the token with the new seed. And if I do this and I inject this new seed right in the middle at the right time, the bike will never move because I blocked that authentication to the engine. So it will not start. So that was my denial of service on the bike.
I have finished my hardware implant for the Scout Bobber to show a proof of concept hack. It has, from the WCM, this connection in the middle with a hardware implant, which will be able to start the bike and drive it off. So now I'm going to go demonstrate that.
Okay, so this is like my implant. I mean, a little bit bigger than obviously the one with the crypto wallet yesterday. But it was going to sit underneath the seat, and here's the Can Pico, which has access to do the logic. The Python script is going to monitor the bus and do all those attack steps. It's being powered off of the wire harness that I'm plugging into with a 5-volt converter. Yeah, so I'll let you see this. Could I have you turn it up just a little bit more? This is a more lengthy video. I wanted to bring the bike in. That would have been cool, but it's way too far from Indiana to bring it here. So this is going to simulate an attack. My user rides up with their bike and shuts it off to show something that I've developed for the Indian Scout Bobber. Now, they would go off and do their business. The attacker would have to come up and have access under the seat. So this is a hardware implant. The seat will pop off. And there's an implant that's been developed that goes in between the wireless control module, and it has, this is called the CAN Pico. It's a microcontroller that has access to the CAN bus, and it's powered through the wire harness. So the attacker would come up and take about a minute to get this off. They pull off the antenna, pull out the wireless control module.
Luckily, the immobilizer was right on
and
top.
unplug it.
Literally right on top. I was like, good.
Then they would plug this side in. It is in the middle of a hardware implant. Then this is going to go back underneath. And go back in there. So now the wireless control module is in, and then it's going to be plugged in this side. The board is flashing its light, meaning that it's ready. It's performing its attack or getting ready for that. In here, I do need to put the antenna back on. So this is now ready for the attack. Now this sits down in here under the seat. The seat can go back on now. Okay, so now to simulate what would happen, the hardware implant has been put on in the bike. Simulate what would happen. I'm the owner and I come back to my bike. I have the key fob. This is the primary means I'm going to use to authenticate to the bike. I'd come up to my bike, turn it on. You can see here, come in here, it's starting to start up. The infotainment's starting up. I'd go to start the bike, and I'd put it in neutral. There we go, put it in neutral, and I'd be like, okay, I'm ready to start the bike up here as normal, and the bike does not start. The bike is immobilized. You can see it's in neutral. I'm trying to give it the start signal. That's not working. So they might power cycle again. Say, I don't know what's happened to my bike. The bike is immobilized because of the hardware implant. That's one of the vulnerabilities. So to start it up again, of course, it takes a little bit of time to start back up. The infotainment as well. It's in neutral. Say, okay, I'm ready to take the bike. Normally, I'd give it the signal to start. It is immobilized. So after seeing that, the owner would then have to go get something to transport the bike. The bike's not going to move unless the attacker disables the attack. So then the attacker would come up. Okay, so I'm going to simulate the owner leaving. To leave, the key fob's going in this tin foil, which blocks all of the RF communication. And it's in this box as well. That signal is not going to get out of there. And you will see on here on the bike. So then the attacker would come up to it and simulating the attacker walking up to the bike and going to steal the bike now. They'd come up to the bike, put up the stand. I'm going to do this. By entering this code up, down, on the joystick here, that stops the attack. It's going to require one more power cycle, but then I can drive off the bike. Again, there's no key present here. So here we go. Bike's going off, and the attacker now is able to take the bike because of the implant. The implant knows the secret to authenticate to the engine, and the attack has been disabled. So now it can use that secret as it starts up. Now it's going to be able to start the bike. So the attacker can now take the bike and drive off. Normally, the wireless control module acts as an immobilizer, meaning when it goes off, you see it's blinking here, it's going to try and shut down the bike.
but that has been bypassed. It's no longer going to do that. It's going to try, no, it did not. It would normally time out there and your attack would be done, but it's been bypassed. As you can come up here real quick and see, the other thing, one other vulnerability is that I can also bypass the pin screen. Everything on the infotainment is working as normal. That's another vulnerability that was found. So now the attacker has access to drive off the bike like normal. They don't have the key and they go. And they have a new bike.
All right, I'm about out of time. Thank you. I have worked with the Automotive Security Research Group. They're a CNA specific to automotive CVEs. We've processed these and we released these yesterday in conjunction with, this was disclosed over a year ago. I finished that research, I think about March. Again, this is my first research project. That's the scope of it. We have 7 CVEs related to that motorcycle security system. And now I feel like I'm on the right path. I finally got to the new path of blue team to red team, and I feel happy to be, very grateful to be where I'm at now. So I look forward to continuing research and taking more devices apart and doing more hacking and defeating security defenses in the future. So thank you.